Good afternoon. My name is Amelia Renault, and this is my learning log for Math 2050. On the inside, I have my title page and my learning log rules. This is my table of contents with a description of each entry, the page number it can be found on, and the date I did the entry on. Moving on to page 1, this is about numeration systems, and there are several different types of numeration systems. My personal favorite is the tally numeration system, which uses the single strokes or tally marks to represent each number. For example, this is represented as 5. You count 1, 2, 3, 4, and then 5. And I like that because if you say you have 15, you can easily tell it's 15 by grouping them by 5 with the tally mark slashed across, which is also very helpful when you're counting quickly. These are some continuing on of the numeration system, such as the Roman numeral numeration system. This right here, that reads as thousand. So 1, 2, 3, 4, 5,123. X stands for 10, so X stands for 20, and then I stands for 3. Moving along to, this is some more of the numeration systems, such as the Nichabula example. It's just a continuing pattern, basically. Moving on to the next topic. Let's see. Models of addition. These are each models of addition, set, number line, counting on doubles, making 10, and counting back, with examples of each one. My personal favorite is the set model, where if you have 8 of something here and 9 of something here, they come together and make 17. And that's a good way for me to be able to remember the set model because it's a great visual example. Let's see. These are more models of addition. It's just a continuing on from the previous page. It has all of my different examples of the properties, the commutative, associative, and identity property. And then this is also the properties of whole number addition in here, so I can help remember each name and not misspell or mispronounce the names. These are subtraction concepts, and these are each subtraction concept with an example. My personal favorite is the missing add-in. For example, what do we need to add to the 3 balloons to equal 8? And we figure that that's 5. Moving on, adding and subtracting in other bases. This is an example here, addition in base 5 and subtraction in base 5. I have 13.5 plus 13.5, and in order to add this, we'll take the 3's and give us 6. We'll take the 1's and gives us 2, and then we'll regroup from that 6. We'll take a 5 and add it to the 1, so that'll give us 31.5. Moving on, this is adding and subtracting on an abacus. This is an example of an abacus that we did, and it has the example shown here is 12,211 base 4, and this is so I can remember that you push up each one for the correct number. So that's 12,211 base 4, because there's only 4 beads. Okay, these are models of multiplication, and I have each an example over here, and underneath each example I have the correct name to help me study. My favorite is the Cartesian products method. You just basically multiply, and it shows you step by step each possibility, which helps me be able to remember because it breaks it down for me in better terms. These are all of the properties of multiplication, and each one of them I have written down here on a sticky note so I can help remember the correct spelling. My favorite is identity property. It's so simple for me to remember because I know it's any number basically times 1. So 3 times 1 equals 3 is an example of identity property because it multiplies itself by 1. Moving on to models of division, we have fair shares, repeated subtraction, missing factor, and bar modeling. I love the bar modeling because, like, again, it's a very visual tool, and that helps me be able to remember each one of them. Here I have an envelope, and on the inside I have the names, and I have the examples shown. For example, the bar modeling, 14 divided by 2. So we would take 2, split it into 2, and that gives us 7. Order of operations. I've always remembered it as PEMDAS, or Please Excuse My Dear Aunt Sally, and I've remembered that since I was in grade school. And I created this cute foldable to help me continue to remember for the future. One example of Please Excuse My Dear Aunt Sally is shown right here as an example. It's this long drawn out equation, and in order to better understand it, we would break it down. Please, we would start out with parentheses, so 7 minus 3 is 4. Excuse means exponent, so 4 squared is 16. And then we would, my dear, so multiply first. So we would look, and we don't really have any multiplication, so we'll just go ahead and skip to division and just continue on until we get to addition and subtraction, and that'll give us the answer of 54 once we continue to work out the problem. This is addition and subtraction algorithms. Again, we have some of the same terms, such as the set model we mentioned earlier, and different visual concrete models that we've seen before, and this is just building off of that. I love the concrete model because they're pretty easy to remember. For instance, these solid squares represent 100. The individual long ones represent 10, and the single ones represent 1. And it's really easy to add them because I can see 100 plus 1, 2, 3, 4, 5, 6, 70 plus 4 and 4 is 8, so that's 178. And that's so easy for me to sit there, see, and visualize and add it very quickly. I have all of the different models and the types here with different examples of each one, such as 25 plus 23, which is the expanded form, and just all different types there to help me remember. The lattice algorithm for addition is I love this tool. I've never thought about it this way before until I took this class, and it's honestly so simple to use. For example, 357 plus 74, you add 7 and 4 is 11, you write it here, 5 and 7 is 12, and then you just bring down the 3 with a 0 in the other place, and then you add across. 1, you just carry it down, 2 and 1 you make 3, 3 and 1 makes 4, and then you don't really carry the 0, so you get 431. That makes that so much of an easier, simple way to add that than breaking it all down and writing and carrying and all that kind of stuff. This is the subtraction algorithm and subtracting across 0. This is really similar to the one we just reviewed previously to this because it breaks it down for you again, and you putting it in a table, it helps you concentrate on that one individual row without looking at the whole thing and being overwhelmed. For instance, we have 40,000 minus 32,963. Well, we know 3 can't take from 0, so we have to make it 10. So then we take it from here and continue on until we just take it from each one of them. And then we just subtract down. So 10 minus 3 will give us the 7, and then 9 minus 6 will give us 3, 9 minus 9 gives us 0, 9 minus 2 gives us 7, and then we took away from here, so we don't have anything here. So 40,000 minus 32,963 is 7,037. And like I said, I really enjoy using that method because I can easily concentrate on just the one individual row at a time without having to be overwhelmed by the whole entire problem. Mental math, addition and subtraction. I wrote down each and every way for mental math, and I have a fun envelope here and it has on the inside all the different ways, so I can help study by using that as like a little note card. I love, let me see which method I love. Here it is, the drop the zeros method. Instead of looking at this huge problem of 5,200 plus 3,600, minus 3,600, you just drop the zeros and you look at what you have. You have 52 and 36, and that makes it so much easier to just add those two together, and then you just add the zeros back. So you don't have to sit there and, do each one of them and carry, and you just do 52 plus 36 gives you 88, and then you're done. You just put those zeros back and you're done. Addition and subtraction and estimation of rational numbers. I have all the different model types here just so I can remember all of them, because it is several model types. My favorite is area because it's very visual. For example, let's just say we had 1/4 plus 2/4. That'll give you 3/4. And this isn't the same exact example, but it would be similar. And it would be so easy to sit there and look and see 1 and then 2 will give you 3. And it's easy to look at that with fractions because it helps understand them better, I think, in my personal opinion. There's some more ways. Let's see, algorithms of multiplication. I like to multiply horizontally. Here I have all the algorithm types here, and just again a little quick flashcard for me to be able to study them and memorize them and know all the different ways. The multiplying horizontally I like because it's basically like distributing, in my opinion. You do 60 plus 7 and then 50 plus 3, and then you just multiply the 60 and the 50, the 60 and the 3, 7 and the 50, 7 and the 3. Then you get this big, long, drawn-out mess, basically, and then you add it all together and you get your number. And I like that, such as distributing, because it's very similar to that, in my opinion, and that's a helpful way to remember how to multiply horizontally. Those are some more algorithms of multiplication. This is the same concept we used earlier, the lattice multiplication. It's very similar to the addition, whereas you multiply, diagonally, you add diagonally and get your answer. For example, 145 times 46, we'll do the 5 times 4 will give us 20, 5 times 6 will give us 30, and so on and so forth. And then we'll add them diagonally to give us our answer. For instance, 0 will carry that down. 4 and 3 is 7. 6 and 6 is 12. Plus 4 will give us 16. We'll write the 6 and carry the 1. 4 and then 2 is 6. So that'll give us 6,670 for that answer. And that's so much faster to me than doing the very long, drawn-out multiplication problems, because I struggle with those sometimes, even to this day. These are some division examples. I love the good old-fashioned long division. I use it all the time in everyday life, and I still will continue to use that long division just because it really, like I said, it shows every single step. For example, 3 divided by 378 divided by 3, 3 goes into 3 one time, and then you bring down that 7. 3 goes into 7 two times, bring down the 6, and then bring down the 1 and carry that 8 down. 3 goes into 18 6 times, and then you're left with nothing. So 378 divided by 3 is 126 perfectly with no remainder. And that long division it's always proven to me to show it's great. I've used it forever, and I will continue to do so. Multiplication and division and other bases. I use this great little portfolio here. It's how to go from base 10 to another base. And it has every single step. Like step 1, you divide. So if you go from base 10 to another base, you're going from 10 to smaller, you divide. In order to go from another base to base 10, you have to multiply because you have to get larger. For example, if you go from base 5 to base 10, you're growing, so you're going to multiply. And this is a great little portfolio that shows me each step on how to do it. For example, 341 base 5, I need to get to base 10, so I'm going to multiply. 5 to the 0 is 1, 5 to the 1 is 5, 5 squared is 25, and then I multiply. Let's see. Okay, moving on. mental calculations of multiplication and division. And this is so many different ways. And in order for me to remember every single way and every single, rule that goes with each way, I have a helpful little tool here, and it's a little note card, and it has an example. And then underneath each example, I guess which the correct answer is. For example, I like to think money. I'm a bank teller, and I work with money every day. So I constantly think about money. So I like this because it's 64 nickels is how many dimes? Well, I know nickels is half of dimes. So I know 64 divided by 2 is 32. And that gives us our dimes answer. And then we multiply that by the 5, and that gives us our 320, which makes it so fast. And I work with it every single day. So it's nice using that outside of work as well. Estimation of whole number multiplication and division. Again, there's so many different ways, and I have each way here, a little foldable with each way, and then I have the examples down here, and I have to guess which example goes with each foldable. I love the Russian peasant multiplication, having it and then doubling it. And then you mark out your evens, and then you add all of your remainder answers to give you 132. So 11 times 12 is 132. And you can do it so quickly. Like I said, it's so much of a faster way than writing it all out and carrying and doing the zeros and all that mess. Estimations of whole number addition and subtraction. Again, this is several different ways, and I have a foldable here with each example, and underneath it has the example of how to do each name. For example, the grouping to nice numbers. We'll just do that one. 23 and 49. Well, 49 is close to 50, and 23 is close to 25. And looking at, let's see, 64 is kind of close to 60. So all those kind of together give you approximately 100. Then 39, and let's see, 39 and the 64 gives you another, it just kind of, 100 and 100, it gives you 200 approximately. But if you sit there and you added each one of them individually, it would give you a little bit more, but that's why it's approximately. So at least you can guesstimate or get a close number on it by using the grouping to nice numbers. Estimation, rounding, and range. We've used estimation our whole life, and so using it on a greater scheme, I believe, helps branch off of those great building blocks we got when we were younger. For example, right here, 4,700. We all know above 5, it rounds up. So 4.5, it would out round up. So this is 4.7, so it rounds up to 5. 3.3, it's below 5, so that'll round down. So 5 plus 3 gives you about $8,000. Banking gives you about 8,000. And then moving on to divisibility. This will be our last topic I review. Divisibility, I created this great little wheel, and it has each number, and then under each tab, which also reminds me of the fractions that we learned about. Under each tab, it has the examples under each of them. I like all of them, but personally I love 5s and 10s because they're basically the same. If the number ends in a 0, 200, for example, 10 will go into it. If the number ends in 5 or 0, 5 will go into it. So, and that's very easy because you just have to look at that last digit. You don't have to look at the whole rest. It could be 10,550,000, but it's going to work because it ends in a 0 or a 5, and that makes it so much easier to just look at it and know. But that's all I'm going to review today. At the end of my learning log, I have my note to the teacher, and that's about it. Thank you. Have a good evening.